acceleration. So next week, next Wednesday, from 2:30 to 5:30, we have our midterm test. The range is from the beginning to acceleration part. Okay, so plus this lecture and the next lecture, right? So before the class test, we still have 2 lectures. Okay, but the next lecture's content will not be in the test content. Okay. Until here. Until the relative acceleration. So I don't quite understand why so many people are not here, keeping absent, and ask for A plus at last. It's not reasonable, right? Because this subject is very fundamental, not just for dynamics, okay? Also for your mathematics. Some of you, I don't know, full-time or part-time, but you're all in this subject, right? So this fundamental mathematics will be useful in other subjects, and you will know that once you are in other lectures. It's not a single subject. It's compulsory. So what makes the compulsory? All right, you should think about it. And this is just a part, right, from the textbook. When you check the textbook, if you got chance in library, the thickness is okay, centimeters for one book. Together with fundamental mechanics, 2 books like this. So you need to pay more attention. Okay, so this is maybe the last chance you can pay attention to those mathematics and think about the fundamentals behind that. After that, when you become an engineer, okay, there's not a chance to pick up your textbook and go in depth, right? To learn those things. For those knowledge, when you know that, right? But for some skill, if you cannot learn how to deal with it, the problem solving, it's very hard, extremely hard to learn it by yourself, right? Just as to cherish this atmosphere, okay, to learn something together, just as the gaming bar, right? I wrote this example at the beginning. So although everyone can afford, maybe most of us can afford a computer to play games, but there's still a lot of gaming bar, right? So just to cherish this atmosphere. Maybe you'll be suffering from those thoughts, right? And confusing. But when you learn it, when you understand it, you will find the value of those things, its benefit. But I actually, to be honest, I do not want you to, okay, to force you to sit here and learn from me, because maybe it is because my lecture is not that easy, not that attractive, makes you okay absent from my class. Maybe it's my problem, but yeah, as I said before, I would like you to learn more from this subject. So yeah, let's continue. So now we in acceleration part. So actually, we last lecture we stopped at a example here, and we just revisit those material from here. Okay, so relative acceleration. Actually, once we talk about relative something, that means a rigid body in general plane motion. Okay, if it is in a rotation, if something is rotate about its center in the rotation, there's no need to use relative. This word, there's no need to use relative because if we want to find a point's acceleration, we just use alpha cross r plus omega cross v, right? No relative things because for one point, we just one step find the absolute acceleration. And if a rigid body in translation, right? If it translates like this, so if it has a translation from here, okay, to here, the path may be like this, and this path same path, okay, and when we move this the path PATH, okay, move this path to this path, they can overlap, right? So we call this as a translation. In translation, we also do not need a relative acceleration because when we know the acceleration of this point called A, and if we want to know B acceleration, actually we can just use the equal. AA always equals to AB in translation. So if a rigid body in translation, we know one point, then we know every point on it. We just repeat. Okay. In Mandarin, 如果是平动的一个钢体，我们不需要相对运动的。你知道了一个点，你就知道了所有点，画等号就可以，所有点都是重复的。如果是转动，也没有必要用 relative motion， 因为只需要这个圆心是一个公认的一个固定点，那直接是带公式就可以了。Okay, so when we will use relative only when translation and rotation happens simultaneously on a single object. We call that general plane motion. What makes it general? Because it has two parts, translation and rotation. Makes a general plane motion. So for this general plane motion component, actually there are four typical components. First one is we have A point and 2 point and B point, and these 2 points slide on their own track. We call this component as double slider. It's not in rotation. AB, not in rotation, not in translation, right? General plane motion. And the second one is a prime slider, means we have A and B, right? A and B. We link them together. One is in a slider, right? One slide along the straightaway. The other rotate about a center, right? We call it a prime slider. And third one, AB. Okay, so A is in the rotation, right? Fixed point. And B is in another rotation. Okay? Both A and B rotate about the center. And third one. The last one is a wheel rolls on its way. Okay? When this wheel rolls along a straight way or curved way, and this wheel is in general plane motion. 很好记的，你就看它两个端点，通过两个端点 两个都走直线，但是不是重合的，那它就是 general plan motion 啊，AB。两个端点，一个直线，一个画圈，也是 general plan motion，两个都画圈也是 general plan motion。另外一个特殊的就是这个轮子滚动，四种很好理解。这四种可以用来解构几乎所有的 mechanical component。这个意思。以后做 mechanical design 离不开这四种结构。Okay, so that's why we call it fundamental, right? So when you go into the examples, it belongs to one of those four cases. Okay. So when we revisit this problem solving step, we can see we just find a component in general plan motion and list their acceleration there. And for these two accelerations, AA and AB, there is a ABA, a relative acceleration, link them up. Relative. So why? Just as the heat, right? Heat of an NBA player. So maybe you can take it as Yao Ming's heat, right? Everson's heat, and their relative heat, right? Or age, right? Age of someone else, and the relative age, right? So who is older and who is younger, right? So similarly, velocity, right? Velocity is same. Velocity of we can come back to here, right? Velocity of a point and velocity of another point and their relative velocity. Actually, relative velocity is there difference, right? Is there difference? So what do I mean by difference? You can move it, right? So it means VB. Oh, sorry. VB minus VA is VB slash A. Makes sense. Absolutely, right? We just move VA to left hand side. So we can see the relative just means the difference. 相对和它们做差是一样的，对不对？ Same thing in acceleration. Everything has its relative quantity. Also in temperature, right? Temperature in Hong Kong maybe 23, okay, and temperature in Guangzhou be 16. So what is the relative temperature? Just to make the difference, right? Relative, what I want to see, relative is difference. Yes, delta is also a symbol to see difference, right? It's the changes, it's a variation. So for the acceleration, same thing. So the relative acceleration, actually, it is AB minus AA, right? It's AB taking A as a reference. So the reference is always the one to be subtracted. Okay, taking the reference always the one to be subtracted. So this is the relative acceleration. Okay, this is the first perspective. On the other hand, what makes it different? Think about it. 是什么让 AA 和 AB 不同的？是什么让 VA 和 VB 不同的？是哪个动作？ Two options: translation, rotation. Which one? Rotation, right? So very clear. In translation, I just told you AA always equals to AB, right? In translation, every point has same path, right? They just repeat the other points. So you're gonna have a sense of safety, right? 在处理 translation 的时候，你应该有一种安全感。你找到一个点，你就把所有点都搞定了。translation 的意思就是这个意思，所有的点有相同的运动，相同意思是所有都可以画等号。你找到一个 acceleration， 你不会找其他的。But the rotation, it does not, right? Rotation for points in different position, no matter in pure rotation or rotation that happens together with translation, right? As long as there is rotation, sorry. As long as there is a rotation, we're gonna different acceleration, the difference in velocity. So the relative motion is only related to the rotation. Here is why we just in the formula we just use the rotation part because the translation part. Okay, so when point B in translation part moving with the reference point A, AB equals to AA. This is the contribution from translation. So what is the contribution from rotation? It's the relative motion. That's it. Based on this principle, you can manage the acceleration and the velocity. Okay, so in rotation, okay, when we consider the acceleration in rotation, there are two parts. One is AT, tangential, right? The other is AN, normal. 一个是切向加速度，一个是向心加速度。向的是哪一个心呢？ Reference point is the center. Okay, so when we use this expression, this formula, A is the reference. A is the reference, right? Point A, the reference point, is the center of rotation. Okay, so when you swap A, you want AB to be a reference, then they're gonna be alpha AB. Alpha AB cross R taking B as a reference, put A in front, minus omega AB squared times the RB, RA taking B as a reference. Again, a reminder for your test and examination, do not write it like this, RAB, unless you know it is an AB link, okay? So if you want to use the relative position, you just do not forget the slash. Slash means a notation, okay? So slash just tell your audience, you taking the letter after slash as the reference. Okay, without such a slash, there's no reference. Okay. Same to the velocity and acceleration, right? If you take, okay, this means a velocity, and do not forget this this vector hat. Okay, I make it in black. Do not forget such a vector hat. Otherwise, it's gonna be a number, a scalar. And if you write b here, okay, this is velocity of b. If there appear a slash here, okay, I make it in red. If there's a slash, it means it is a relative velocity. Relative with respect to what? Maybe to c. Okay, so this means relative, taking c as a reference, velocity of point B in vector. 1, 2, 3, 4, 5. 5 elements. Okay. Check your assignment. Do you made some mistakes like this? Maybe not, because in your assignment, there's no relative motion. Right? So do not make a mistake in your assignment 2 in the future. Okay. And test. Okay. So we can talk about the example one more time. Okay. In this example, we analyze the acceleration. And this acceleration, we want to know the acceleration of piston at the instant. This is the piston. So firstly, step 1, okay, when you come back, step 1, you need to find out the component with general plane motion, because it is the complex motion, right? We're gonna find the key point of this problem and try to do some analyze. All right. So we want to know C's acceleration, and we know its acceleration is about this block and the end point of this link, right? This point. And also we find this link, the link BC, is in general plane motion, because point B rotates, right? Circular motion around A, and point C has a moves in a straight way, right? It moves up and down. So B and C are in different motion. Therefore, BC is in general plane motion. So we just need to apply a relative motion analysis to B and C to find the relationship between them. So you always want a formula list, right, from me. So in order, in case you cannot remember such a complex expression, actually there's no need, right? So you just look at B and C. Okay, just cover your page, okay, and just with a white paper. So we have 2 points, B and C, okay. So if we take C as the reference, B as the target point, right? We want B, okay, we want B, and we want C as the reference. So AB is AC, right? And C is a reference. So it must be C as a reference, and B here, relative acceleration. That's it, right? Once you go to this order, B and C, you can just expand it, because here is B/C. So when you expand this part, it must be alpha BC cross RB/C minus omega square BC RB/C, right? 2 parts. For this BC, this just means BC the link, BC or CB same thing, right? Because it is not a relative things. Just alpha BC belongs to the rigid body. Okay, wherever you go, as long as you are on that component, you can use alpha BC. Okay. Or alpha CB, same thing, right? Alpha BC, BC means 2 points can determine a object, right? Alpha BC is alpha CB, same thing. Also V, right? Velocity BC. So velocity no. Omega BC, also omega CB, same thing. Because there's no relative alpha relative omega in our expression, right? So you just put down AC here, right? And put down AB here like this, so you know everything. So there's no need to remember, right? You just know the ABC, those order, right? And you can expand it. Okay, and when we continue, we find. So when we continue, we go in detail. There are 3 points taken into consideration. One is point B. The other is point C, right? The last one is BC's relative, right? So when we consider point B, we need to use the condition from the rotation, right? Point B has its rotation part, right? A, B. That's why we have this one, alpha AB cross RBA minus omega square AB times RBA. RBA here is a vector. For C, it just moves up and down. We do not know the magnitude, because the magnitude is what we want. Everything is right. But we know the direction. The direction is in vertical direction. Vertical direction can be positive J or negative J, right? We are not sure. So we can just use the J to denote its direction, and AC as an unknown letter for its magnitude. Okay, so AC is in this way. And for the rest, we just repeat those elements and find them one by one. Right, AC is ACJ. Alpha AB is given, is 20, right? So alpha AB is 20 negative K, because it is clockwise. Clockwise negative K, counterclockwise positive K, because by default horizontal is X and vertical is Y, and K is from the paper point out perpendicular to the paper. Okay, this is the Apple pencil is K. It is C. Okay. So every rotation happens in this plane. Therefore, the axis must be parallel to C, to K, right? Positive K or negative K. So that's why we use K so fast, right? Each time. So this is alpha AB. we just neglect the unit because the unit is in SI. SI means the international unit system, okay? Meter, second, radian, right? Alpha AB, RBA, RBA. RBA means B's position minus A's position, right? You just remember, when taking the point is the reference, we just, this point is the one to be subtracted. 谁是参考点，谁就需要被减掉。什么？为什么那个加速 C 的加速度是这个 ？C 的加速度，要不然呢？它有可能是负 J， 它有可能是负 J， 但是我们不确定。We are not sure positive J or negative J. We just know it is positive or negative. So, here, the direction is in. Okay. Any other questions? It's very important because in your test, there's another slider, and you will be asked to find the acceleration. I just tell you the truth. Another truth. There must be many of you cannot get the full mark. Okay, so RBA from A to B. Okay, so one more time, from reference to the target, RBA from A to B. Right hand rule. Which right hand rule? For what? You mean alpha AB? So your question is? Why negative K? Why? If you have an axis here, we must right? We must use axis like this, right? So this is x, this is y. But this axis it should be z, right? Z is positive, right? Us, right? Out. And this one is clockwise. So you put out your right hand, right? Use your four fingers, same as this direction, and you see your thumb when inside the A. Another question. So those details will become the deduction. Okay, will be the negative marks. So pay more attention. So remember, before the last time, okay, make as much as mistakes as you can. Okay. Otherwise, you will make mistakes in your exam, in your test. It's true for everything. So it's very good to make mistakes on class. That's what we do. From A to B. So A to B is 0.25 feet, right? And Oh, it's not SI, right? Because this is in feet. Okay, so 0.25 is the magnitude. What is the direction? Direction from A to B, right? 45 degree to the vertical, also 45 degree to the horizontal, right? So it is 0.25. Okay, I component and J component. So we can use two steps from A to B. First step, go vertically, right, to B level. Second step, go horizontally to B, right? Vertically is 0.25 times cosine 45 is the vertical part, right? J. And horizontally is negative I, right? Times sine 45. This is the relative position RB, taking A as a reference. 这个就不要挖了，这是你中学的东西，你不要挖给我了。应该挖你中学老师为什么不好好教？And you just do it again, right? Omega AB square, right? Omega here. Remember, here is a number, not vector, right? So omega AB, you just put it, use 10 square, right? And no need to do it here, right? RBA, same thing, right? And then alpha BC. Okay, alpha BC. Do we know the direction? Alpha BC, do we know the direction? Alpha is the angular acceleration. Angular acceleration is for the rigid body. 希腊字母都是给到 rigid body 本身的，所以看到希腊字母，那就是 rigid body 它的旋转，再看到旋转，那就是 k。所以你放到最后就是看到希腊字母你就想到 k。那仅限于 planar motion，OK。你如果之后遇到 3D 的情况，你就不要这么联想了。那它一定是 alpha BC positive or negative, right? K. So this is two parts, right? First part is the magnitude. Second part is the direction. But for this one, it's possible to have a negative number for alpha AB, for alpha BC, right? But it doesn't matter, right? Depends on the solution. When you find, okay, alpha BC is negative 5K, it does not mean it's really in negative. It still have a magnitude is still 5, right? It just means the direction is negative K, that's it. So in this case, you will interpret this solution as 5 radians per second in clockwise. And that's how you translate this amount to the layman, to one who are not an engineer. 对吧？工程师做什么的呀？那电脑算出来这么个数字，你要给你的甲方解释一下这是什么意思？怎么出负数了？负的速度什么意思？对不对？你不用跟我解释，我知道，你们是我的甲方，我跟你们解释。Okay, so that's it. And move on. RCB, taking B as a reference, come to C, right? From B to C. Horizontally, 0.75, right? And 13.6 is here. So horizontally is 13.6 degree in sine, right? This one gonna be in sine part. as a I component. Absolutely, the rest one is the cosine as in J component. All right. If you are not familiar with vectors in mathematics, you highly recommended to go to the textbook, the appendix. There are 5 pages tell you the whole part of vectors. Okay. All you need to know is there. I also share a YouTube video to someone of you, so you can also share to your group, WhatsApp group, or you can come to me to see which video, and you can also come to that video to see the vectors knowledge, the vector skills. Okay, so this one, and then omega BC is given, right? Omega BC is 2.43 given. And at last, the RCB also given. So we just substitute everything into this equation and just do the calculation. You will find maybe at the left-hand side, you just have a J component, right? ACJ. At the right-hand side, you will have something I plus something J. For J, we just say use a triangle. Okay. So in this case, the square is the coefficient of I. The triangle is the coefficient of J. AC is the coefficient of J. So here we have equal sign. Equal means the coefficient are same. So firstly, for I component, left-hand side, there's no such a component. So their equivalent, it is the 0I. Therefore, left-hand side is 0 coefficient. Right-hand side is the square, right? And for J component, left-hand side is AC. Right-hand side is the triangle. But do not draw like this on your paper. Okay. And okay, so you can do it by yourself, and actually you can also visit the textbook, and this is an example problem on the textbook. You can find a comprehensive steps on that to check your calculation. Any questions? Okay, if no, we just have a 10 minutes break. Okay, let's move on. Let's move on. And we need to so you should use your textbook frequently, because most of the examples I just picked it from the textbook. We have very good textbook, and relative motion acceleration. This one. Okay, so as you can see here on the textbook, so once we have such a formula, and we put everything into this formula, right? So ACJ equals to, okay, expand it, right? AB this one, and alpha BC is this one, right? We just substitute, find this. So finally, let's see what happened. We got a equation like this. Only I and J component, right? So they are all about the I and J, no K. Why? Because K is vanished because of the cross product. We use K to cross I because J is there, right? When K plus J, we're going to isolate. So K will disappear because of cross product. So I just would like to remind you, friendly reminder, do not forget to write down cross. Okay. I found dot product in our assignment. It's absolutely incorrect. Say if omega, we can say omega cross R. We see this operation is a cross product, and you cannot write like omega dot R. It's incorrect. Incorrect. This one is correct. Dot and cross is different. Okay, do not use dot. Why? You can Google. Because we will talk about this in the next chapter. Next chapter, we use dot product to find the energy, to find the work. Only in cross product can you find another vector. Okay, if you have two vectors, you find another vector. There's a cross product. Or you can come to the textbook. Okay, textbook appendix and vector analysis. Vector analysis. You see, 1, 2, 3, 4, 5 pages. So you can see the cross product. What is the cross product, and what is the dot product? Dot product is here. Okay, you can find the difference between them. Okay. Hey. Okay, yes, that's this. So what I want to see later. So we see if we put everything back into the equation and do the cross product, what happened? What happened? We have we have such a equation, right? And we do the cross product and we put it downside, right? And put everything together, we got a expression. There are two cases. Case 1, it is the I component. Case 2, it is the J component. Just the two, right? Something J, something I, something I, something J. Okay. At last, you only have two cases, right? Something I or something J. There want to be the third case. There's no something K. Something K disappear because of cross product. 因为 K 一定会和 I 或者 J 做 cross。K 一旦和它们 cross 一下 ，K 就没有了。所以说，你到最后算出来的算式一定是关于 I 和 J 的，只关于 I 和 J 的。那左手边只有一个 J， 没有 I， 那说明左手边 I 是0。右手边把 I 的加在一起 ，J 的加在一起，那你就会有两个算式，关于 I 就是这个，关于 J 就是这个。两个算式，两个未知数， 两个倍数阿尔法解出来 OK 了。所以呢 ，so when you finally you got you got an expression like this. Remember in your examination, this is necessary to put a I and J component, this equation group here. It's a important step. Without this step, you cannot solve the equation. Okay, remember to put those equation group. Okay, so after that, you find, okay, I got a negative number, right, in AC. We just assume it is ACJ. So now we got a negative number. We substitute back, we got it is a negative something J feet second square. It means it is 13.5 feet per second square to negative J. Okay, to negative J. It is time consuming. Okay, it's a so after you understand this process, it costs a lot of time to solve this equation. So just work hard to practice more. Okay, last one, a special case. Relative acceleration in rolling. Relative acceleration in rolling. 你开车往一个地方去的时候，你想象一下你的车轮是怎么运动的。虽然不能下车去看，但你可以看其他车，对不对？哦，对，在等红灯的时候，可以看一看这个车辆转起来之后，它那个车轮哪个点上面很有趣的。你会发现这半部分运动的快一些，这半部分运动的慢一些。尤其踩单车的时候，你们如果去郊野踩单车，你看一看你同伴的单车，你会发现靠近地面的部分，你能容易看清楚它的轮毂；离开地面这一部分，你看不清。如果你上次课听过了，你就可以解释为什么，对吧？I mean, if you look at your bike, okay, the wheel of the bike, and there are two halves, right? So this part, okay, it will be blurred as you speed up, and this part is always clear. Why? Because point A is the point that touches the ground, right? Once a point that touches the ground, it has zero velocity. Zero velocity. So this is the zero velocity, and this wheel at this instant just rotate about the zero velocity point A. So if a point is far from A, it has a large speed. If a point is close to A, it has a slower speed. Therefore, we can see different speed on this wheel. Oh, it's a very good it's a very good chance to use a computer. So you can use a color map. You can use a color map in your computer to plot the variation of the velocity or the speed at different points. And color map on this wheel and see for each point you can plot. You can use a color to represent the value of the velocity, the value of the velocity. So at last you will have a color map, and you can just see the color range of this wheel to check the different velocities. I just want to put it into assignment 2 so that you got a chance to practice your programming. Okay, come back to the acceleration. For such a wave, if we want to analyze its acceleration, it's gonna be different because in such a wave, it seems different from those things. So if you have you can interrupt me at any time, but do not go with me. 对，一直是打断我，因为你也可以替我。Okay, so for such a whale, when compared to the links over here, it's different, right? Because it's not easy to find a reference point, right? It's not easy to find a reference point. For those links naturally use the ends as the reference. But for such a whale, it's not easy to find a reference. So how to get the reference? Actually, there are two typical points. One is the center, special point, right? One is the center. The other is a point that contact the ground. 两个重要的点，一个是中心，一个是地面上的。So for these 2 points, their acceleration, I want you to understand the bottom line. For the center point, its acceleration follows the horizontal direction. Think about why. For the bottom point, its acceleration always went up. Leave the ground. Think about why. Chinese. 因为中心的这个转轴这里，它的加速度永远是平行方向的。比如说跟道路是平行的，接触地面的这一点，它的加速度方向永远是向上的。为什么？中心的这个发光了，对，然后那个另一边那一点就是因为它这个东西这种acceleration，中国可以只有它的这个二个very good. So firstly, point O is constrained by this wheel. Because the existence of such a wheel, point O can only stay in this level, right? Otherwise, the car is broken, right? So, point O, that's the peak in this level, right? It cannot go up, neither downward, because of the existence of this wheel. That's why we can confirm the acceleration, the velocity are all go in this straight line. Okay. This is the center point. On the bottom point, for the bottom point, if this point is in the bottom, you can imagine what will happen next instant. 下一个瞬间，它要离开地面，对不对？首先，这个车轮是不打滑的 ，no slipping, not slippery. Okay. So next instant, this point will leave the ground. Once it leaves the ground, it goes up. So from zero velocity to a very small velocity upward, it must have an acceleration point up. So these two are not from the mathematical derivation, but from the physical facts. 它们是事实啊，就是说，首先那个中心的那个点，它一定是水平方向，因为这个车轮在那里。那地面这个点呢，它下一刻一定是离开地面，所以说它一定是向上的加速度。这两个是事实，这两个呢没有明显的数学的推导，所以说呢，你们要多理解一下这两个这个 natural facts. So we can see the animation. Not this one. We can see the animation of the wheel. This one. So this is a whale, and for those who are absent from this lecture, I just give them a mercy. Otherwise, they cannot see the animation. Okay, so here we have a whale, right? And okay, it doesn't matter. So when we see this wheel and we give this wheel a motor and let it move to the right, and you just check the acceleration of an edge point and a center point. Actually, edge point's acceleration is much larger because it rotates in an accelerating. Therefore, their AN is AN, right? Normal acceleration becomes larger and larger. And at the center, as you can see here, the acceleration is very small red segment. That's the point to the right. Right. This is just a SolidWorks simulation. Did you learn computer-aided design, such as SolidWorks or other equipment? Yeah. Not just limited to SolidWorks. SolidWorks is just the start point. You need to come to the next level. Not just the SolidWorks. Try to export the SolidWorks model to different places. When export as STL, then go 3D printing, right? Print it out. And you can also export those 3D model to MATLAB, the same scale, and to do some simulation of dynamics, simulation about its control. So just SolidWorks is just a start point. It's a basic requirement. Okay, start from SolidWorks, just do more things. So this is okay. We just stop at a specific position and let's see its acceleration. Okay, here, and Where is my mouse? Oh, what happened? So when I zoom in, as you can see, the point that touch the ground, right? When it leave the ground, it has an acceleration point to the up, right? Going to up. And this acceleration just point to right hand side, right? So we just remember this two directions and stop the sharing. And we switch back to here. So the other one is about the quantity. The quantity horizontally, its acceleration will be like this. Yeah, for one thing, you can have a relative acceleration from A to O, like the red color part. Okay, we're taking A as a reference and O as a target point, and because of this, this is a general plane motion. We apply relative acceleration from A and O, so we find AO must equals to A if we take A as a reference plus AO taking A as a reference must be like this, right? We expand it, we find AOI, right? AO is horizontal, equals to AAJ, AA is vertical, equals to their relative acceleration, these two, right? 我们发现一个有趣的事情，把这两个在一起之后呢，你就发现 I 和 I 这个互相做一个相等之后，你就能够得到 horizontal 和 vertical 两个 acceleration 分别是 AO 和 A。这两个是我们要用的。AO is alpha cross ROA. AA is negative omega square ROA. So to explain it, you can see AO actually is alpha ROA. Okay, in scalar. Okay, 它两个相乘 I, right? And AA here, assume it is acceleration, not deceleration. Okay, so AA, the vector is omega square ROA, right? And point up, right? Or J, right? Or J, same thing. So when you ask why here is negative ROA, because this negative is for the direction. Because if we write down such a vector RO slash A, that means from A to O. A to O is correct, right? RO taking A as a reference, A to O is correct. So AA is positive. Okay, sorry, it's positive because you see negative AAJ, right? And is negative omega square ROAJ. So AA is omega ROA. It's positive. From A to O, right? From A to O. Just make sure the direction is correct. Okay. And let's find a example to apply this rule. Okay. We have a disk that has an angular acceleration 8 radian per second squared and the angular velocity of 3 radian per second at the instant. If it does not sleep at A, determine the acceleration of point B. Okay, point B is here, 45 degrees from vertical, and we want its acceleration. We want its acceleration. The acceleration of wave will not appear in text. However, you will see that finally it's important. Okay, so if we want to find the acceleration of point B, what can we do? We can do it like this. Firstly, find the acceleration of a reference point, point O. And taking O as a reference, apply relative acceleration equation on BO. It's a good idea. Method 2. You can also find the acceleration of point A and apply the relative acceleration on AB. You can also find the result. Okay, so let's see the method 1. Okay, find the acceleration of center point O. Acceleration alpha is 8 radian per second squared, counterclockwise. Okay, counterclockwise. That means the acceleration direction is to the left hand side, so it just accelerates in this way, right? Because of the counterclockwise. You can also check the in vector, right? In scalar, you just identify or recognize its left hand side direction of AO. And in vector, you can just calculate, right? In the vector, you just use alpha cross ROA, right? AO. We find AO first is alpha. Alpha is 8 radian per second, positive K, right? Because counterclockwise. X is to the right. Oh, sorry, this is X. And Y to the topward, right? And C point out. So AO is positive 8K cross ROA from A to O, 0.5 positive J. Okay, these two do the cross product. It is 4. K cross J is negative I meter per second square. This is alpha. This is AO. So once we know the reference acceleration, it's easy to find the acceleration of any point, as long as we know its position. 只要找到了参考点的速度，加速度，那我们就可以解锁对任何一个点，只要知道它的位置，可以找到它的 acceleration. Do anything you want. So for point B, okay, we want to find AB. AB is AO. O is a reference plus AB taking O as a reference. So for calculation, you just AB equals to AO is negative 4I, right? Plus ABO. We just expanded, okay? AO plus ABOT. So alpha AB. or alpha, just the alpha, because there are only one alpha, right? There's no need to use a subscript. Alpha cross RB, taking O as a reference, minus the omega squared times the RB, taking O as a reference, right? So we just negative 4i plus alpha is 8k cross the RBO from O to B, from O to B, this direction, right? So horizontally it is 0.5 meter cosine 45, right? Or sin 45, whatever, right? Sine 45. And vertically minus 0.5 cosine 45, right? Horizontally is I, vertically is J, all right? RBO, this is RBO, right? Minus omega squared. Omega is 3. We just use a number, right? 3 squared RBO. We just repeat it, right? 0.5 sine 45 degree I minus 0.5 cosine 45 degree J. That's it. So you just calculate one by one and sum it up. Finally got the result. AB is the one you want. Is it on the textbook? Let's check. Oh, on textbook, we have another one. It's similar, right? We just come back. Okay, no more for the calculation. You just do it by yourself. And this is the rolling. And also, we have another example. Just to give you 2 more minutes, this one. And you can have any question. Yeah. Which one? J. Here. Right? Here. No. RBO. O is the reference. Start from the reference to the target. Reference is always the start point. That's why we put a reference. Okay. We're always in this.你要心中有坐标系才可以，知道吧 ？Reference 是 O， 那你的心中一定要有一个这样的坐标系才可以。你看它在这边，它的 I 方向一定是个正，它的 J 方向一定是个负。Okay. That's why. Yeah, you can discuss. Discuss. 我们给他们看，哎 ，AO AO. Where is the J component of the AO? Because it is stopped by the ground. No, AO. O cannot move down because it's stopped by the ground. That's why. This is AO. This is R. This J is R. Yes. Because yes. This is the model. And that's the with 8 times 0.5 as the magnitude for the four. One direction, negative I, right? So the negative I is to the fourth, negative I of the man. If you do it, if you do it in vector, you can find these connections. And after applying this vector, you get the number, and you do that. See, there's no way to find it. There is the only thing you find is a lot. But that means that the formula is correct. Yeah. We have the formula. RAO is alpha cross ROA. Alpha. Not use dot. Cross. ROA is here. Actually, the position that okay, this is about the. We have another example. You see, we have a whale, okay, and it released from the cord, right? And at the instant, it has an angular velocity of 3 radian per second and an angular acceleration of 4 radian per second squared. Okay, both given. Determine the acceleration of point B. This is maybe last year's test question, right? Or the year before last year. So for point B, we want to find the acceleration. How to find it? Firstly, what is going to be the animation? Oh, sorry. So when we check those wheel that rolls vertically, and it will be like this. But when you imagine before watching the animation, it will be like this. I did not draw the chord. And you just let's see. Okay, you can just slow it down and goes down. And this line is It's a vertical ground, right? And in this case, when we stop it at a specific position, okay, at a specific position. Okay, just maybe here. Okay, stop at this position. We find something. We find, for one thing, for the center, the acceleration is parallel to its ground, right? The center acceleration is parallel to its ground. Now its ground is vertical, right? And the edge acceleration, okay, edge acceleration, this is not the edge. Actually, the edge is this part. Is the blue highlight, right? Blue highlight is the edge. And the red one, this highlight, okay, this the outer part is just embedded on this wheel, right? So this is the true edge, right? But because it is a rigid body, right? This is a really rigid body. Therefore, as long as we know the geometry of this rigid body, as we know the position of point B, right, we can find its acceleration. Okay, so okay, one more time, let's check the acceleration. Okay, you see what happened. It accelerates vertically, right? 这个整体加速的话，在中心应该一个向下的出现向下。为什么向下呢？它不能像从这边呢？因为这里有个原生的 constant， 这个So center point is very effective. Okay, once you see a wheel, you just consider the center point. Okay, and we can come back. Acceleration of point B. Okay, so firstly, find the first step. Find the acceleration of the center. The center is also the reference we're going to use, right? Point G. So second step, apply relative acceleration, right? Relative acceleration between the target point and the point G reference, right? So let's do the first step. For point G, AG is, if you are not familiar with the vector, actually you can just use the numbers, right? Alpha times R. Alpha is 4. R is 0.5. And the unit is feet per second square, right? So this is the magnitude. And the direction, it accelerates downward, right? Point G accelerates downward because it is center. We know its direction. So downward is, we can take it as a negative J. Therefore, we know AG actually is negative 2J feet per second square. That's it. This is the reference. And once we know the reference acceleration, we can use relative acceleration analysis to find point B. So point B, actually AB is what we want. Is AG, the reference, plus the relative of B taking G as a reference. So AB is AG negative 2J, right? Plus, okay, ABG, we can expand it. AJ plus ABG omega, alpha cross RBG minus omega square RBG. Calculate one by one, right? Alpha is given 3, right? So 3 negative K because clockwise. 3 negative K cross RBG is from G to B because G is a reference. So from G to B is 0.75 feet J, right? So 0.75 J minus omega square. Omega is alpha is 4, right? Omega is 3, but no one tell me. 3 square 0.75 J. And you can calculate those numbers and sum up. You find AB equals to something I plus something J, but here it's gonna be a negative number. One question is it a acceleration of a rigid body or a point? 你要找的是别，你要找的找B的加速度，找 B 的加速度，对不对？那 B 在哪里 ？B 在哪个平面里？正方面这个完题和圆形。Which plane? X Y plane, Y Z plane, X Z plane. 在了。你这样让我很难做。This is the X axis. This is the Y axis. Oh, sorry. Z axis is point out of the paper. So okay, this is the example. Oh, sorry. And 10 minutes break. Okay, 10 minute break, and later we'll continue. Alpha 是一个 vector, R 一个 vector， 它两个放在一起做什么？为什么两个都加箭头？做什么？
加一个 AG
是吧？AG 你的 cross 呢？你的 cross 呢？它不 cross， 它到底是什么操作？你 alpha 写在这里 ，R 写在这里，这两个都是 vector， 对不对？这两个都是 vector， 你这两个 vector 你需要做什么操作？操作是 operation。那你不写出来是点还是叉？那别人怎么知道你是要做什么操作？你自己也不知道呀，对不对？ 你自己也不知道吧？
啊，
你不知道这里是要做 cross
我
product，
知道
知道你要写出来的。
啊。
OK，那我的问题来了，这个 R 是什么呀？R 是一个 position vector，你把 R 这么一写，它是一个 position，谁的 position？相对于谁吗？它是一个绝对的 position，怎么的一个 position？是什么呀
啊
？R G A 呀，
哦，
对吧？你这样的话，你才能去找它的 position。
这不是有一个这个
对呀，你你要看这个，你要看这个公式啊，你看这个公式，这个公式是什么？你如果要找 O 的话，O 是目标点，对吧？A 是参考点，A 在哪里？A 是它的接触地面的点。
哦
那相对于这个来讲的话，它虽然变成竖直方向了，那竖直方向接触地面的点是不是这个点？
哦，可以用这个
所以说你要这么找。
啊
哎，所以你把它俩放在一起，你 cross 一下，你是不是自然就得出来是个这个？那然后才算出来的。
好的，谢谢。
外面这个收费是哪里可以看到这个东西？
你是解这个方程组啊？
我找到这两个方程，然后就找它就
你不知道怎么解是吗？
对哇，对，这个 EJ ECJ，然后就有上面这个 equation，然后这个是什么？还有
哪里？
这个
这个？你去计算呀，你把它们都算出来呀。
这里是两条公式了吧？
不是，你看这个是21.21i，对不对？这个还有一个其他1.04i，对不对？然后呢，这个还有，这个是18.45，这是关于 J 的。关于 J 的，你看这是-14.14 J，然后呢，这边还有个4.30 J，那这两个合并一下，那不就是-18.45 J 吗？
行，然后这个就是 I，然后下面这个 J，
对呀，
然后就 solving u，然后就把它
你就解这个方程组，你跟上面没关系了。
OK， OK，明白了，谢谢。
老师又明白了什么？老师，我忘了这个图，这个关系图，因为上面是负 k 减负 k 乘对吧？是这样看的吗？负 k 乘这
不是，你先回到你那里，你看，你先别管这个负，这就是 k cross j，k cross j 是什么？负 i，负 i 那前面还有个符号，你这个时候再看这个符号，负 i 就是正的。
好，
哇，你的快的这么3天了。
所以他那个我套的就是他这个号是反复的，他只是一个就是他这个没有特定意思，
有特定意思。就这个意思是什么呢？我再解释一下，阿尔法你知道是个意思吗？对吧？这个 ROA 呢是指的我们要找 AO，所以说我用的是 O 的位置，对不对？O 的位置，那对 O 的什么位置呢？O 相对于接触地面的那一点的位置。谁在地面谁就是 A。你像这里，我们看后面这个，
不是我的意思是这个 R 本身 R 的那个意思，就是它只是就是那个
R 是一个位置矢量 position vector，
就只是一个就是一个数跟一个我说嘛，个人可能它不像 A 一样有一个特定的，它是它才会存在
啊。有啊，它特定意思就是位置矢量，
就是位置，
对，就是 O 的位置矢量。
就是我要加一个位置矢量放上去的时候，我用它的，就是这个意思。
对，是就是你看这个，也就是说，对于一个 rigid body 来讲，你肯定是这个 rigid body 的什么呀？它叫什么来着？角加速度差成一个位置矢量，才能得到加速度。所有的这个
我的问题好简单的，我慢慢的看这个是，
我看看啊，AB，J 上面的箭头呢
OK，
？AB 等于2J AB， 哪个题目？
？AB。
OK，你问我这里算出来对不对？
对。
我看一看，
我的字有点丑。
没有。负二 J 这是 AG 的部分，对吧？负二 J，然后后面呢？后面是两部分。你那不就是这个吗？
我想知道怎么说，他知道了。
answer 对不对？是吗？
对。
那就是看一下书有什么。你们都不看的，我白上传了。
看你们。
那我上传做什么呢？那都有 answer 你都不看。
是这个吗
？ABX 是3啊，对的。ABY 是-8.75，-8.75啊，对的。
这一颗特别难了。
这个对，这不怪我，这不是我发明的，对吧？这不是我发明的，我只是把它传递给你们，我只是一个传递者。
上面来。
没有学完这个，你再学其他的，你就觉得很简单。就像喝特别苦的东西，你再喝一口清水就很简单。你说
前面这个
因为我
对上一个题
上面一题，
last question
上面一题，这个是吧？这一题，
对，
你要找 AO 嘛，对吧？AO 是这样子的，你要看这个公式的，这里是公式的，虽然是手写题，它是公式的，它是找什么呢？你看，我要找 O 的加速度，我就等于什么呢？角加速度差乘 O 的位置，对不对？这很合理吧？我要找 O 的加速度，所以说要用到 O 的位置吧？那 O 关于谁的位置呢？关于地面的位置，也就是说 AO，所以说就是个真理。你找谁的加速度就是用谁的位置。
然后还有那个 reference point 是
reference point，你对那个 point 知道的越多，它就越被适合用 reference point。
还有，
对，你不要找一个无名小卒，你像这里，你像这一个，你不能随便找个点你 reference。那像 G 一样，我们很容易就能算出来它的加速度，那拿它当 reference 多好啊！它不会，对，它不会引入新的 unknown。对，都是这个原则。
还是懂了一点，
会越懂越多的。
懂了一点。
OK。哎，
谁有点不明白为什么这个要写非常 J 在这儿
啊？
还是可以不用写？
你前边这里写了，后边就要写了。你前面这个 AO 吧，AO，
对，
那它证明它是一个 vector。那你要 apply 这个 formula 的时候呢，你就需要 vector 差乘 vector。
对，
这什么意思呢？就是说这个 vector 是什么？是角加速度。你要找的是 O 的加速度，对不对？
对。
你要找 O 的加速度，你就要用到 O 的位置。那这个 0.5J 就是 O 的位置。
对。是因为在 A 的上面。
对的。那不写有不写的版本，不写是什么？
新的那个。
不写就是两个都不写。
所以
你看不写，不写就是这样啊。4乘以0.5是什么呢？4乘以0.5我只算什么 magnitude， 但是呢左边有箭头了，右边也
单位这样。
不是单位啊，单位矢量。对。
好。
Okay, let's move on. Next part, note 5. Okay, so let's summarize this part before the test. help you to targeted review. So for the kinematics part, and firstly, you should understand vector. Okay, how to use a vector to express a position, a velocity, a acceleration. Right, we did a lot. You should know what is a vector and how to calculate. Right. So every variable, okay, every variable listed here has its vector form. And second one, although I did not emphasize, I want you take into consideration the unit system, not just in 3002, but in other subjects such as thermodynamics or other subjects. Okay, you name it. You pay attention to the unit. Okay, so unit is actually it's interesting when you consider, okay, the unit, you can identify different variables, and you can even check the answer is correct or not. For a rigid body, if it rotates, there must be a unit of angle, unit of angle, unit of angle, right? If you consider the velocity, keep quiet, please. Thank you. If you consider a angular velocity, must be divided by a time, right? Divided by a time or a time, right? This is the velocity related unit. This is for rigid body. For point, there must be a unit of length as its position. If the position change as time goes, and we want to know the change rate, it must be consider the rate divided by time. So there must be a velocity of point. Okay, this is velocity. So if we continue to know the rate of velocity, okay, the rate of rate, therefore we have a rate of rate 2 times rate, right? That's why acceleration we use second square. That's why in acceleration we have a second square. It's the rate. Okay, the rate of rate. First, the rate is velocity. Second, velocity is rate is acceleration. So we have a second square. Okay. I believe seldom people explain this in such a detailed way, right? No one told you. So based on their unit, you can see, okay, so when we have reading per second, okay, and we want to know meter per second. Reading per second is a rigid body's motion. This is a point's motion. From a rigid body to point, reading is just the ratio, right? Meter is a length, right? And when we draw equal here, there must be another what? Unit, ALO, right? ALO is a position vector. Position vector means position is length, right? Distance. So there must be a meter unit here, right? That's why we have omega r equals to velocity. Okay. Similarly, you can find the similarity of meter per second square, right? Alpha r is this one times meter, right? This one times meter. You got meter per second square. All right. So you should not ask whether it is a acceleration or velocity, because based on the unit, you can tell apart what it is. Okay, it's very important. So this is what we call a unit system. 这个很有意思。其实有一个特别有意思的一个物理教本，它解释了为什么在草原上的兔子，他说它跳的那个高度不能够超过多少，他说它长的那个大小不能超过多少，可以用 unit system 分析出来的。我如果找到的话，下次可给你们分享一下。unit system 非常有意思。Okay, and okay, so then it's about rotation, right? For rotation, we should know about the velocity and the acceleration, right? And in 3D case, you will use this. And 2D case is it's a mistake. In 2D, it's omega square r. Okay. One more time. Why we have a negative here? Did you have such a question before? We have a O here, right? We have point P here. And why we have a negative here? Why minus but not plus? Do you have such a question? You wondering? Okay, if you have, let me explain, okay? Because RPO is from O to P. This is RPO. RPO. Disappear. 为什么付钱越多，这个软件越不稳定 ？RPO from O to P. However, this is normal acceleration, 向心加速度. This acceleration, we want AN from P to O. AN is from P to O. This is AN. So AN is opposite to RPO. That's why we need to do such a compensation. 给它补偿一下，给它调转一下。OK， 因为 RPO 是从中心指向 point P 的，但是我们要找的这一个是从 point P 指向中心的，所以要给它加个负号调转一下。这个是为什么？多年以前，我尝试先把这个东西解释明白，然后再告诉大家怎么去用。但是解释完之后，发现大家都不行，所以今天我们就直接放弃，你先用，对吧？回来之后知道这个是什么问题，再来解释。当然，可能依然有人不明白。Okay, this is rotation, and then we come to relative motion. Relative motion, you just need to know it has two parts. One is translation, the other is rotation. Sum it up, we got a general plane motion. And we should know the relative velocity formula. You just write it by yourself. And the relative acceleration formula, write it by yourself. And you should know the IC method in solving the relative velocity, because it can save time and efforts when you use the IC method. IC means instantaneous center of zero velocity. Oh, so long. I just you can just read your textbook. Okay. And after that, I just to some representative problems. Call them representative means it is helpful for your test. So I want you to do it one by one without checking the answer. Try pick it as your test paper and see whether you can solve it. For sure, it is not the test paper, but you can find some similarity at the next week. So if we have a gearbox, right, ABCD, and we know the acceleration, angular acceleration, and how to find the rest gears acceleration, right? No. Determine the time required for gear D. And also find the number of revolutions of gear D to attain this angular velocity. And maybe how to say, this question is good, but maybe not that highly related test. But I want you to know how to solve this problem. So A, B, C, D is here, right? A and B, there is a graduation, right? Alpha A over alpha B is RB over RA. So you can find the B. B and C are same alpha, same omega, right? C and D, they have their graduation, right? Alpha C over alpha B is RD over RC, right? So based on that, this chain, you can find alpha D from alpha A, right? Don't forget the chain, right? Don't forget the chain. So you want to know alpha D, and you know alpha A, right? From alpha A to alpha D, you can do it like this, or from D to A, right? Alpha D. Firstly, you can introduce alpha C. When you divide it by alpha C and make it equal, you should time alpha C as a compensation, right? And then you can divide alpha B. And then you can time alpha B. And then divide alpha A. No need to time alpha A, right? Because alpha A is what we have originally, right? So as you can see, we can draw an equal in between because alpha C can be eliminated. Alpha B can be eliminated. So there's still alpha D over alpha A. What we did is just introduce these variables to make it simple to link up alpha A and alpha D. So in this case, we can find alpha D over alpha A. We can do it one by one. DC is RC over RD. CB, same shaft, right? C and B share same shaft. And it is a 1. Then BA, RA over RB. So finally, you can calculate those ratios, right? Don't forget the chain. This is the first one. And this is the answer. Second one, at the instant, just read it by yourself. Okay. And this one, one more. The power of a bus engine is transmitted using the belt and the pulley arrangement shown. If point P has its velocity and acceleration 2 meters and 3 meters per second square, we got its velocity and acceleration. And acceleration of point B. We want to find the angular velocity and the angular acceleration of point C, a pulley C. How to deal with it? 怎么找？ VB. Oh, not VB, VP. Right? It's point P. Red point, point P. VP is omega D, RD. Right? It's omega D, RD. We know RD. We know VP. We can find omega D. Right? We can find omega D. Once we know omega D, we know omega D equals to omega B, right? Because BD shares same shaft. Once we know omega B, we know omega C, right? Omega C over omega B has a ratio, right? RB over RC, right? We can find it. This is the omega. And then the angular acceleration, you do it in the same way, right? Because we know if we know AT actually is what? It's the tangential acceleration at wheel D, right? At wheel D. For this point, we take it as A, B, C, D, E. Okay. For point E is here. Okay. Point E is here at the edge of this small wheel D. Okay. Point E is here. Actually, it is a point E's tangential acceleration, right? Tangential acceleration. So it is alpha D times RDE, right? RED, tangential acceleration. Then we can find alpha D here, right? We can find alpha D. Then alpha D is alpha B, boy, dog, okay? And then alpha C over alpha D is RD over RC, same thing. RB, RC, sorry. B and C because they share the same belt, right? And you can find the result. Yeah, that's a similar question. 哎，我都快把 test paper 搬给你了，你一定要努力。这个，如果大家都考满分，你不要埋怨我做的太简单。不会显示出你的聪明才智。应该不会。OK，再看一个 representing representative problem. OK, the rotation in 3D. Rotation in 3D, you just focus on those formula. So once there is an axis, right, we want to find point C's velocity and acceleration. 这个 answer 你不要学它，你要加上 hat， 不要学我。哎，这个要加上 hat， 对，这样子。The key point is how to denote omega the vector, which means when you know the magnitude, which is 5, right? And how to find the unit vector. How to find the unit vector. Unit vector, it point to right, right? Omega and alpha both point to the right because it is counterclockwise if we look at it from right hand side. 从这边看的话，它是逆时针的，所以说呢，它就是 positive J，positive J 啊，因为这个是 3D， right 3D。So it is 5 positive J， 然后呢，再去算就可以了。Point C。Point C in I direction, it is negative 0.4 I, right? In J direction, we do not know, right? In J direction, it's not given. Point C is here, right? Not given. But in K direction, along C, it is 0.3 K. So this is RCA. But what about in J direction? You will find it doesn't matter because J cross J is 0. No matter what it is, you got a 0 for this part. Therefore, it's only related to I and K. One more time. We do not know for C point, for point C, we know the X is 0.4 negative, right? And for J, we do not know. Do not use X, we use L. Okay. For K, it is 0.3. But no matter what L is, it doesn't matter. Because if you substitute, right? If we want to know RCA is from A to C, right? From A to C. A to C is a C position minus A position. A position is 0. So RCA is 0.4 negative I plus LJ plus 0.3 K. And we substitute to here, right? And you find the J component, J cross J is 0. So L part is eliminated, right? It's disappeared. Therefore, only related to I and K can find the result. And for AC, actually, I just recommend you use this one. AC is alpha cross RCA plus omega cross VC, because VC is solved, right? You know VC, you just use 2 cross product to find it. Okay, and move on. Relative motion. Given such a current slider, if the block C moving downward 4 feet per second, determine the angular velocity bar AB. Point C downward. Point B downward. So VC, tell your secret. VC equals to VB because they're parallel.刚好遇到两端的速度相同的方向，那这两个速度一定是一样。如果不一样的话，因为它两个相同的方向，那这两个速度在这个 VG body 上面沿着 BC 的这个投影它是不一样的。投影不一样的话，那就会把这个什么或者压缩。这两个速度，我讲的是这个意思。我有点茫然的，看到我。I mean, BC direction is here, right? These two velocities are same because if we do a projection from this to the rigid body, we got this projection, right? VC projection, okay? And for this one, we got a VB projection on the rigid body, okay? Projection. And this one is VBP. VCP and VBP are two velocity projections along BC. These two velocity must equal to each other. If not, if this one is faster, this one is slower, then BC will be correct. Right? And if this one is faster, this one is slower along this rigid body, it must be right. Rigid body means along a specific segment, the velocity component to be same. Okay, this is a fast method to solve this problem, right? You can just identify this. So actually, you can also use the vector method to solve it, right? VB moving downward is given by AB because AB is horizontal, right? And it has omega in clockwise. Therefore, VB is downward, right? And you can still take it as a VBJ, right? You can still take it as a unknown to calculate. Actually, it's VB negative J, right? Because it moves downward. So you can still write like this, right? Negative. So VC is VB plus omega BC cross RC, taking B as a reference, right? You can still use the safe method, right? The vector method make you safe. So VC is negative 4J. Is VB. VB is negative VBJ. We do not know, right? Plus omega BC. We do not know. Omega BCK cross RCB from B to C, right? Because B is a reference. So it is 3 cosine 30 degree I plus 3 sine 30 degree J. So we can have such a expression. We want to know AB, right? We want to know angular velocity of bar AB. Therefore, we need to further expand this expression. I mean, okay, left-hand side, we just keep it there. But for VB, negative VBJ, we need to further expand it, make it contains alpha AB, omega AB, right? Omega ABK cross RBA, right? VB is omega ABK cross RB, taking A as a reference, right? This is from the rotation. So RBA is from A to B, is 2I. Therefore, we have two unknown, omega AB, omega BC. And for this vector expression, vector equation, we have two components. So two components means two equation, two unknown. It can be solved. Omega AB is 2. Nothing new. Okay, the next one. And the position shown, bar AB has an angular velocity of 4 clockwise. Determine the angular velocity bar BD and DE. AB is rotating about A. DE is rotating about E. So AB and DE are both in rotation. So BD is the one in general plane motion. So what you need to do is to link up VB and VD based on the relative motion, right? Just the answer is here, right? So you just link up VD and VB like this, right? Don't forget the vector hat over it when you handwriting. Okay, so once you link up VD and VB, you can express VD and VB by rotation. 这个题其实挺热闹的，你如果写出来，你看 VD。Okay, we're taking B as a reference because we know AB, right? We're taking B as a reference to find VD. Actually, VD is VB reference plus VD taking B as a reference, right? And in this case, we can expand them. Firstly, VD is omega DE. Omega DE cross RD, taking E as a reference in this rotation, right? And VB is omega AB cross RB, taking A as a rotation, all right? So put them together, we got, firstly, VD, we just repeated, right? Repeat this one, this is VD. This is VD equals to VB. Okay, VB is this one. Okay, and plus VDB, right? VDB is omega BD cross RD, taking B as a reference. So finally, you got the 3 omegas and the 3 R. And they follow this equation. And you just substitute them and find out the solution. All right. We want to find the angular velocity bar BD and DE. So bar BD and DE, right? So they are unknown. We just expand it. Omega DE K. 毫无疑问是 K, right? Cross RDE. RDE is from E to D. E to D. E to D is here. Sleepy? Okay. So you can do it by yourself. And because we have the answer, right? So I think you can complete it after class. Okay. Last one. Oh, you got a similar one. Crank slider. When you find the acceleration similar to this one. If you can solve this one independently, I'm sure solve the test. If you cannot, if you solve this one successfully, but did not fail to solve the one in test paper, and have to me, and I will show you why you solve this. Okay, actually, this one is maybe a little bit complicated than the test. So pay more attention to this one. Crank slider, and okay, I'll give you the final answer. Just show you the method. Okay, the velocity at point C is given. Acceleration at point C is also given. Okay, velocity at point C and acceleration at point C both given. All to the left. 也就是说 VC 是往左边的 AC 也是往左边的 OK 都知道的 Find the angular acceleration of link BAB and BC. Find the angular acceleration of link AB and BC. And you find there's only two members in the motion. I mean 3.86 and 17.7, right? One is point acceleration, the other is point velocity. You need to find the angular accelerations of AB and BC. So how to find it? No worry, just start from the velocity analysis. First step is to do the velocity analysis. To find omega AB and omega BC, because you will use it in next step. And the second step, you find the acceleration. Relative acceleration. So for the relative velocity, you just find out the T component, which is BC, right? Because B is in curved motion and C in straight, moving in straight line. So BC is the one in general plane motion, right? General plane motion. Therefore, omega BC and omega AB can be expressed like this. So VC is okay, is VB, right? It's VB plus VC taken B as a reference. So omega, VC is given, right? It's omega AB cross RBA plus omega BC cross RCB. Solve this. Find the two omegas. Acceleration, do the same thing. AC is AB plus AC taking B as a reference. So AC is given, okay, just put it here. But AB, because B has a circular motion around A, it's like an egg. So circular motion around the A gonna be like this. So point B is here, right? Circular motion around A. So its acceleration has two parts. Firstly, tangential acceleration. Secondly, is the normal acceleration. So it has two parts, ABN and ABT. So ABT is alpha AB cross RB, taking A as a reference, minus omega square AB. You have solved this in last step from here. And times RB, taking A as a reference. And this is VB, AB, right? Plus ACB. ACB is alpha BC cross RC, taking B as a reference, minus omega BC square, right? You solve it from here. And times RC, taking B as a reference like this. Solve this, you can find these two alphas, alpha BC and alpha AB. Because as you can see here, AC is given, right? Alpha AB is alpha ABK, right? And RBA is given. Omega AB, you solve it here. And alpha BA, you given. Alpha BC, not given, right? So alpha AB, alpha BC, not given. And then RCB also given, right? And the omega square, you solve it last step, RCB also given. So the only unknowns are two, alpha AB and alpha BC. Okay, so test guide. 4 questions. 25 times 4. And Q 1, 2, 3, 4. And the formula, you will see these 4 formulae. This one is wrong. So do not trust my formula. And yeah, those four questions, I just briefly describe the questions you will encounter. And okay, some common mistakes. Every component has its significance. Arrow, letter, B/A. Okay, each one you should know what it means. And also, do not write dot product. It's a cross product. Okay. And then, again, do not forget to use a cross in the numbers, between the numbers, because I saw someone of you write like this. What do you mean by that? All right. Without a dot or cross, I don't know. What do you want to do? So just pay attention to those typical or representative problems and try to solve it by yourself. Okay. And if you have difficulties or questions, you can You can send me WhatsApp message. Oh, okay. So much for today's lecture.